As I told you, we are going to discuss equations of rotational motion. When a rigid body is making the rotational motion about a fixed axis of rotation, then suppose this is a fixed axis of rotation, about it is rotating. Then what are the important equations? As I told you, it is very much similar to the equations of the translatory motion. Let us consider a rigid body is moving with the uniform, it is rotating with the uniform angular acceleration. Uniform angular acceleration. Angular acceleration is alpha. That means alpha is equal to d omega by dt. I remind you, you just compare it with the translatory motion. A was the acceleration, linear acceleration, that is dv by dt. Here d omega by dt. What is omega? Omega is the angular velocity. Angular velocity. I think you all remember this. So d omega is equal to alpha dt. Right? Obviously, integrating, we shall integrate. On integrating, we get integration of d omega is equal to alpha integration of dt. You know, definite integral, I write at here, I write t is equal to 0 to t is equal to t. Here omega is equal to omega naught to omega is equal to omega. This is the limit. Here I write here to make it more clear. Here at t is equal to 0, omega is equal to omega naught, and t is equal to t, omega is equal to omega. So if we here integrate it, on integrating, what we shall get? Omega will be the integration. Here omega naught to omega. Alpha is a constant quantity. T will be here. T is equal to 0 to t. I write it like this. That means omega minus omega naught equal to alpha t minus 0, which implies omega is equal to omega naught plus alpha into t. I write this equation 1. I hope you can remember it is very much similar to V is equal to U plus AT. This is why repeatedly I am telling you it is very much similar to that you can say translatory motion. So omega is equal to omega naught plus alpha into t. This is the first equation. Let us now move to the next one. Now angular velocity omega equal to d theta by dt. What is theta? Theta is the angular displacement. Rate of change of angular displacement is the angular velocity. Theta. इसका मतलब क्या होगा? d theta must be omega dt is equal to omega naught plus alpha t dt. Right. Then integration of d theta is equal to integration of omega naught plus alpha t into dt. And definitely here I write t is equal to 0 to t is equal to t, because here t is the variable over which the integration is taking place, and here theta equal to theta naught to theta equal to theta. Theta equal to theta naught to theta equal to theta. As usual, you know what will happen here according to the law of integration, omega naught dt. Here t is equal to 0 to t is equal to t plus alpha will be taken out, t dt, t is equal to 0 to t is equal to t. Because हम लोग पढ़े इंटीग्रेशन में तो ऐसे ही होता है, दो पार्ट में आ जाएगा. So how much we are getting? Theta theta, theta naught to theta equal to omega naught, here t 0 to t plus alpha, you know, t dt, integration of t dt is t square by 2, 0 to t. So what we are getting, theta minus theta naught equal to omega naught t minus 0 plus alpha t square by 2 minus 0 square by 2. So final expression, theta minus theta naught is equal to omega naught into t plus half alpha t square. It is, I hope you all are remembering, it is similar to s is equal to ut plus half at square. In place of s we have written x minus x naught. Initial position, theta naught is the initial angular position, थीटा इज द फाइनल एंगुलर पोजीशन. दोनों के बीच का जो डिफरेंस है वो एंगुलर डिस्प्लेसमेंट है. इज दैट ऑल राइट? आई होप इट्स क्लियर टू यू. एंड नाउ फाइनली let us come to this formula again. Okay, we are now coming to lastly we are coming to finally what we can get, alpha is equal to d omega by dt is equal to d omega by d theta into d theta by dt. Can it be written? Here also, if you remember your previous discussions, I hope you all will be very much aware, d omega by d theta is equal to omega, or we can write omega d omega equal to omega d omega here equal to alpha d theta. Again, I will integrate it. On integrating, what we shall get, integration of omega d omega equal to alpha will be taken here d theta, and you know at t is equal to 0 theta naught, t is equal to t theta, so I can write corresponding limits, omega is equal to omega naught to omega is equal to omega, and here I write it is equal to theta equal to theta naught to theta equal to theta. Look, I can write it in this way, or we can say here it is omega square by 2, limits will be omega naught to omega is equal to alpha, here theta, here it is theta naught to theta, which implies omega square by 2 minus omega naught square by 2 is equal to alpha theta minus theta naught. I hope it is sufficient up to this mark. When I am showing it, then I can directly write the value, that is omega square is equal to omega naught square plus twice alpha theta minus theta naught. This equation, this is equation number 3. Look, just check this equation. Very much similar, repeatedly I am telling you, very much similar with our previous equations of kinematics, calculus method. We have done calculus method. These are the 3 important equations of rotational motion. Very much similar to the translated motion. You can just study these. Today we are doing up to this mark, right? Try to grasp all these things and make a notes of it. Okay? Thank you.